viewers, welcome to MR.Wanyoike, the digital learning platform. In front of you is MR.Wanyoike himself, ready to present a mathematics lesson, and we are on lesson number 2, Form 1 work, and we are going to look today on factors. And as far as factors are concerned, it is the second unit, unit 2 of the book 1, that is Form 1 work. And as far as factors are concerned, I'm going to come up with example 1, that is the prime factors. Example 1. I'm going to deal with prime factors. I'm going to deal with prime factors, and as I said in the previous lesson, a prime factors is a number which has got only two factors, that is 1 and itself. And therefore, in this example, as far as prime factors, I can write example 1 below, because the heading is the factors, and therefore in example 1 you are supposed to write all prime factors between 0 and 20. So as far as this question is concerned, what is the solution to that question? You write all prime factors between 0 and 20, and therefore you are going to write the solution to it. The answer becomes, the first one is 2, the first answer to that is 2. The second one we have 3. The third one we have 5. The other one is 7. The next one is from 7 you are supposed to move to 11, then 13, then 17, and finally we are going to write 19 as the next one. And therefore as far as all prime factors are concerned, you are supposed to write it is 3, then you go to it is 2, then you go to 3, then you go to 5, then you go to 7, then you go to 11, then you go to 13, from 13 you move to 17, and lastly you get 19. And this the second area that you are going to look in this particular lesson, we are going to look on composite numbers. Composite number, that is the first area of study was prime factors. The second area is the composite numbers. And you can be asked, what is a composite number? A composite number, this is a natural number that has at least one divisor other than 1 and itself. Meaning that it has got more than one of more than one of the factors. As far as 1 and itself is concerned, there are other factors which are involved. An example of this question, you can be asked, write between or composite number between 0 and 20. I can refer to the same example which we referred in example number 1. So you are asked, write all composite numbers between 0 and 20. Still, what is the solution to this? Between 0 and 20. So the solution to this, we are going to take the numbers. A composite number, as I have already defined, I've said that a composite number is a natural number that has got at least one divisor other than 1 and itself. And therefore, from 0 to 20, the first one becomes 4. Why? Because we cannot pick 1, we cannot pick 2, we cannot not pick 3, because 1 has got only one factor and or divisor, that is just 1, and 2 has got 2 devices, that is 1 and 2, and therefore 1 factors. 2 has got 2 factors, that is 1 and 2, and 3 also has got 2 factors, that is 1 and 3, and therefore if we come to the 4, 4 has got more than 2 factors, and therefore 4 becomes the first composite number. The second one is 6. The third one we are going to move to 8. The other one we are going to move to 9. The next one we will get it as 10. Then we move to 12. Then we move to 14. Then from 14, 15. Then from 15 we have 16, and from 16 finally we are going to get 18 is the last one, and therefore we have those are the composite numbers that are found between 0 and 20. And we go to the next example. As far as the next example is concerned, the example 3. This was the first example. I have given the second example of the composite number. I'm going to look on another example 3 here. Example 3. And as far as example 3 is concerned, the question reads, express the following composite. Express the following composite numbers as a product of the prime factors. And the number given here in this case, in this example, is 472. 472. So how are you supposed to come up with the factors of 472? We can use method 1 here. Method 1, and method 1 is referred to as a tree diagram. You come up with a tree diagram that is 472. Then you ask yourself 2 will get you will get 2 36. That is 2 times 2, that's 6, you get 472. Then again 2 that 6 is divisible by 2, so you divide it further by 2, becomes 1, and this is 8, becomes 8. And moreover, you are supposed to come up, actually this was example 3A, because there is also part B, and 2 again. You will move to 2 again. You will get 59, and after getting 59, that is a prime factor, and therefore you write 59 and 1. And therefore, having said that, as far as we want to express that number in terms of its prime factors, you are supposed to write 472. Remember, that was the question. 472 was the question. Then should be equal to 2. How many 2's are here? 1, 2, 3 raised to power 3. Then you multiply by 59 raised to power 1, and therefore the answer becomes 2 raised to power 3 times 59 raised to power 1, and that becomes the answer to our question. The second part of the question, still in this example 3, you are told write all factors of 472. Write all factors of 472. So as far as the first part of the question is concerned, you can see I came up with a tree diagram, and all the factors are reflected on the tree diagram, And as far as that question is concerned, we can write all factors. The answer of those factors, the first one becomes 1. You can see 1 here. The first one is 1, and the second one is 2. You can see how there is a 2 here. It's 2. That is the second one. That is 2. And the third one is 2. You multiply by 2, you will get 4. The fourth one is 2. You multiply by 2, then you multiply by 2, you will get it as 8. Then from 8 you will move to the fifth one, which is supposed to be 59. 59 here. 59. Then the 59, you can multiply 59, you multiply by 2. If you multiply 59, you multiply by 2, you get 118. So 118 is another one. And from 118, we'll move to 236. You can see it is well illustrated here, 236. And from there, you will come to the last one, which is supposed to be 472, because 472, if you multiply by 1, you'll get 472, and therefore that becomes the last one, and that is 472. And therefore those are all the factors that they are all the factors of 472. So the first one, we've said it is 1. The second one is 2. The third one is 2. You multiply by 2, you will get 4. And 4, if you multiply 4 by 118, you are supposed to get 472. So 4 becomes a prime factor. And also 2, you multiply by 2 times 2, you'll get 8. And 8 you multiply by 59, you'll also get 472. The third one is 59. And 59, if you multiply by 8, you are supposed to get 472. And the other one is 118. If 118, if you multiply it by 4, you are supposed to get 472. And also the other one is 236. If you multiply 236 by 2, you are supposed to get 472. And lastly is 472. You multiply by 1, you will end up getting 472. And therefore that gives us the answer to that. The next example, I'm going to give example number 3. Example number 4, sorry. Number 4. And in our fourth example, you are told express 300. Express 300 in terms of its prime factors. In terms of its prime factors. So as far as another method is concerned here, I'm not going to use the tree diagram. I'm going to use the long division method, that is 300. I ask myself, which is the smallest factor which I can put here, so that which is divisible by 300. So the answer is 2. You divide by 3. 300 divided by 2, you are going to get 150. Then another factor 2, you will end up getting 150 divided by 2, you get 75. Then another factor that I put there is 3. 75 I divide by 3, I will get 25. Then I put 5. 25 divided by 5, you will get 5. And lastly I put 5 there. You will get 5. I put 5. The last one should be 5. 5 I divide 5 divided by 5, you will get 1. And therefore I have said 300 divided by 2, 150. 150 divided by 2, 75. 75 divided by 3, 25. 25 divided by 5, you get 5. 5 divided by 5, you get 1. And therefore if I'm told, right, I'm told express 300 in terms of its prime factor. So I'm going to write 300 is equals to how many 2's are here? 1, 2. There are only 2. 2 raised to power 2. And how many 3? Only once. It appears once, and therefore I will write 3 to power 1. And finally, how many 5? 5 are 2, and therefore you write raised to power 2. And that will give us the prime factors of 300. Having said that, I have come to the end of today's lesson. I have come to the end of today's lesson, and I'm going to give you assignment. I'm going to give you assignment, and you're supposed to this assignment you're supposed to find the factors, the prime factors. You find the prime factors. You find the prime factors of the assignment. You are told assignment. That is question 1. Find the prime factors. Or prime factors. Or you can have it this way: express 120 in terms of its prime factors. Express 120 in terms of its prime factors. Yeah. And question 2, write or composite number numbers between 0 and 100. So that is the assignment for today, and I will mark that assignment as the end of this topic, this lesson of today. And your presenter was Mr. Wanyoike, a mathematics teacher. For more information, you can reach me using the following cell phone number. The code of my country, Kenya, is positive 254. Then you followed by 724 901 639. For more information, you can contact me using that number, or also you can also find me on YouTube using Mr. Wanyoike. And till next lesson, bye bye.